Hello everyone. In the previous video, we have discussed about what is a 2x1 multiplexer. In the previous video, as I told you, 2x1 multiplexer is discussed. Now in this video, we are going to discuss about 4x1 MUX. So that is 4x1 MUX. So 4 we can write it as 2 power 2 cross 1 MUX. That is, as I have said you earlier, this is the number of select lines. That is, the 4x1 multiplexer will have 2 select lines, 4 input lines, but only 1 output. Because I told you, multiplexer always has 1 output. 4x1 MUX. So as I told you, 4 inputs. D0, D1, D2, D3. There is 1 output. I just want to add color to my diagram, and hence I am going to represent these select lines as S0 and S1. So this is the simplification of the 4x1 MUX, and this is the block diagram representation of 4x1 MUX. So now we are going to write a simple truth table for 4x1 MUX. So truth table for 4x1 MUX. So 2 select lines as I have drawn here. So there will be 1 output. As I told you, the use of the select lines is nothing but to tell which input should be connected to the output. Hence here will be 0, 0, 0, 1, 1, 0, 1, 1. So D0, D1, D2 and D3. So this is the simple truth table or rule for 4x1 multiplexer. That is, when select line is 0, 0, the output would be D0. And when select lines are 0, 1, output would be D1. When select lines are 1, 0, output would be D2. When select lines are 1, 1, output would be D3. So, if you get confused for which combination the output would be, then I can tell you a simple idea or a simple trick. So, you know that 0, 0 is a binary. These two are binary digits, but the decimal equivalent would be 0. For 0, 1, decimal equivalent is 1. For 1, 0, it is 2. For 1, 1, 3. So for 0, 0, 0, 0, 1, 1, 1, 0, 2, 1, 1, 3. So a simple trick to remember for which combination the output is. So now sorry, I forgot to write the Boolean expression for this. I am again writing the truth table. 0, 0, 0, 1, 1, 0, 1, 1. So D0, D1, D2 and D3. So the Boolean expression for 4x1 MUX would be y is equal to S0 bar S1 bar D0. S0 bar S1 bar D0 plus this combination is over. Next S0 bar S1 bar S1 D1 plus this combination is over. This S0 and S1 bar. So S0 S1 bar D2 plus this combination over. This one is S0 S1 D3. So this is the Boolean expression for 4x1 multiplexer. So I just want to expand the truth table once again. So S0, S1, D0, D1, D2, D3 and Y. This is a big truth table. So you have to remember the rule. When S0 and S1 are 0, 0, output is D0, 0, 1, D1, 1, 0, D2, 1, 1, D3. So when S0 is 0, 0 and when D0 is 0, when D1 is 0 or 1, D2 is 0 or 1, D3 is 0 or 1. In any case, from the rule, we know that when S0 and S1 are 0, 0, output would be the value of D0. So D0 value is 0 and hence here 0. And when D0 is 1 and whether D1 is 0, 1, D2 is 0, 1, D3 is 0, 1, we don't care. We just want the D0 value here. Hence, the output would be 1. In the same way, for 0, 1, when D0 is 0, 1, when D1 is 0, and when D2 is 0, 1, when D3 is 0, 1, output would be the value of D1, that is 0. Similarly, for 1, output is 1. We don't care these values. That is, I can show you like this. X, 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 X. So actually it's not X, it's just don't care. So X, X. This also don't care. So this one, and when S0, S1 is 1, 0, similarly don't care, 0, 1, don't care, 0, 1. And when S0, S1 is 1, 1, I told you the value would be D3. So don't care, 0, don't care, 1. So 0, 1. So this is the expanded truth table for 4x1 multiplexer. So now I am going to draw the logical diagram of 4x1 multiplexer. So now we are going to discuss about the logical representation of 4x1 MUX. As you see here, I wrote the Boolean expression of the 4x1 MUX. So using this Boolean expression, I am going to draw the logical representation, or simply I can say you that building 4x1 MUX using the basic logical gates. So first, as you can see here, 1 AND gate, 2 AND gate. This is one combination of AND gate, 2 AND gates, one combination of AND gate, 2 AND gates, one combination of AND gate, 2 AND gates, one combination of AND gate, 2 AND gates. So 2, 2, 2, 2. How many? 2, 4, 6, 8 AND gates. 1, 2, 3. 3 OR gates, 3 OR gates and 1, 2, 3, 4. 4 NOT gates are required for this diagram. So you have to please excuse me for this a big diagram. So first I am going to draw how many 8 AND gates are required. So I will draw from here. So simply I will represent you. So there may not be a space available. So I can simply write it as S0 and S1, and I can draw 1, 2, 3, 4, 5, 6. So first we'll connect these. So S0 bar and S1 bar. So no, I'll draw in other way. Just a minute. Yeah. So first I'm going to draw the S0 NOT gate, S1 NOT gate, and now I'm going to take one AND gate. So first, in the first combination, S0 bar, S1 bar and D0. So S0 bar, S1 bar and D0. So this is one output, and the next combination. So next combination is S0 bar and S1. So S0 bar and S1. So that is D1. So next is S0 and S1 bar. So S0 and S1 bar, D2, and finally there are no bars. P3, and all are connected to OR gate. This is the final logical representation for 4x1 MUX. As when 1 minute before I told you 8 AND gates, 4 OR gates, or 1, 2, 3, 4 NOT gates are required. So I have mixed these two NAND gates for S0 bar and S1 bar. I have mixed the AND gate, that is, I am simply taking the S0 bar terminal and S1 bar terminal here. You can also draw like S0 bar, S1 bar AND gate, and you are going to connect this and D0. So if you draw like this, then there would be 8 AND gates. In the similar way, for D1, you can take it as S0 bar, S1, an AND gate, and for D1, this is also the same representation. So you can simply decrease the logic gates. So now here we require 1, 2, 3, 4 AND gates, 1 OR gate, here 2 NOT gates. Bas. And this is the 4x1 MUX representation. Thank you for watching the video. So in this channel, my sister is doing the cooking videos, and I'm going to explain my electronic subject videos. Do subscribe the channel and do support us. Thank you.